Hello everyone, this is the maintenance module of the course Ultrasonic Welding Systems Maintenance and Getting Started. Let me remind you that you can watch all the classes on YouTube for free. The playlist link is below. Now we will learn how to perform the maintenance of power ultrasonic equipment in a structured and efficient way, ensuring the tuning and coupling of acoustic stacks. In the first module of this course, the Fundamentals module, we learned about ultrasonic welding process and understood that tuning and coupling of the acoustic stack elements are essential for stable operation of the machines and welding quality. We also learned that frequency deviations and the degradation of coupling between the elements cause failures, including in the generator. This is the second module of the course, known as maintenance. Here, we will address the recommended procedures and the necessary tools to ensure the tuning and the coupling between the acoustic stack elements. In simple terms, the maintenance structure is divided into 3 steps. The first is predictive maintenance, which will be covered in Class 1. Here, the aim is to early detect deviations of the system by monitoring their frequency to identify the need for preventive maintenance. The second subject is Preventive Maintenance 1, covered in Class 2. The goal here is to correct the surface defects caused by the degradation of the element's interfaces and loss of coupling, in order to restore the stack. The last subject is Preventive Maintenance 2, covered in Class 3. Preventive Maintenance 2 is performed when Preventive Maintenance 1 was not sufficient to refurbish the stack. In Preventive 2, the goals are: first, to identify the defective element, the converter, booster, or sonotrode. Second, to refurbish the element when possible, or, in more severe cases, replace the element. Now, we will deal with predictive maintenance by monitoring the stack's frequency in Class 1 of Module 2. Shall we start? To ensure that acoustic stacks work properly, and to ensure tuning and coupling, we must follow some practical procedures. The first one is predictive maintenance, via monitoring of the stack frequency. We learned in the Fundamentals module that a tuned stack is a necessary condition, so it's essential to monitor the operating frequency of the welding machine in order to detect deviations or deviation trends in the running frequency. These deviations, when detected, indicate that we need to do preventive maintenance of the stacks, reconditioning the interfaces and tightening their elements. Monitoring must be periodic and systematic to prevent more serious problems from occurring. To measure the frequency, we can use the sonic sniffer. The sonic sniffer is a non-contact ultrasonic frequency meter. It measures the operating frequency of the acoustic stack during the operation, without having to remove the stack from the machine. Thus, measurements are faster and much more practical. To monitor the stack, we can, for example, once a day, measure the frequency of the welding machines and note the measured value. With this data, it is possible to monitor the evolution of the stack's frequency as it wears out. Interface and sonotrode degradation is a slow process, but it is constantly happening. From the frequency deviation detected by monitoring, we can identify the need for preventive maintenance according to the tolerance specified by the manufacturer of the welding system. If there's no frequency tolerance specification, we recommend that welding machines with variations greater than 0.25% of the nominal frequency undergo preventive maintenance. For example, this stack operates on 20 kHz. 0.25% of 20 kHz is 0.05 kHz. So the tolerance for this stack is 20 kHz plus or minus 0.05 kHz. Put another way, if this nominal 20 kHz stack is operating above 20.05 or below 1995 kHz, we must perform preventive maintenance on it. This is the case here. 1993 is below the minimum tolerance. So this stack must go to the preventive maintenance. But what is preventive maintenance for an acoustic stack? How can we do this? You can check the answers to these questions in classes 2 and 3 of this module of the course. Remember, you can find all the classes on YouTube. Use the link below. In the next class, we will see that restoring interfaces and reassembling the acoustic stack are excellent procedures to correct small frequency deviations. Also, we will get to know some important details of these procedures and the proper tools you need to carry them out. See you there!